Okay, so we are going to do this question. We're going to sketch the solution to each system of inequalities because we've got one on the back too. Now, we need to find the solution to these. Now, what does it mean to find a solution? Well, if you remember, it means we need to find the x and y that make it work. And so our goal is to find the x's and y's that make both of these work. So what we're going to do is we're going to do one at a time and then see what works for both. So we're going to start with this one. We're going to find all the solutions to that first one. So I'm actually going to write it over here real quick. Y is greater than or equal to 2x minus 3. Okay? We're going to graph that like we normally do, but we're going to start, but we'll make one little change to it. First, we're going to start like we normally do at negative 3, so we'll go to negative 3 on the y, and then here's our slope. We're going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and we'll keep going. Now, again, we are trying to find the x's and y's that make this work. Now, if I picked any of these are x's and y's. If I picked any of these and plugged it in, would it work? Would it make it work? Well, let's see. I'm going to pick any of these points and I'm going to plug it in and try it, just for fun. I'm going to pick this one right here to plug in, and that point right there is 4, 5. Okay, I'm going to take that x and y and I'm going to plug it in right here and see if it makes it work. Because if it does, then it's a solution, and that's what I'm trying to find. So I'm going to plug in 4 for the x and 5 for the y. So I'm going to go 5, and then a 2, and then a 4 minus 3. Okay, so that becomes 2 times 4, that's 8, minus 3. So let's look at that. Is that true? Did it make it work? Is 5 greater than or equal to 5? Yes, it is. So that means that that point made that true. And since it's on this line, any of those points, if I plugged them in, would also make it true. So to show that on the graph, that any of these points will be true, like make it work, I'm going to color it in solid. Okay, a solid line. That shows me that any x's and y's on that line will make it true. Now, also, because it's got a greater than sign now we've got to start thinking about points that aren't just on the line. So because we've got a greater than sign now, that means that either any x's and y's on this side of the line will make it work, or anything on this side of the line could make it work. But we got to find out which ones. So we're going to pick another point that's not right on the line and see if it makes it work. So I'm going to pick the easiest point because I like to save myself some work. So I'm going to pick this point right here. And that point right there is 0, 0. So I'm going to plug in 0 for x and 0 for y and see if that point makes the first one work. So I'm going to come over here. 2x minus 3. So I've got it. Oh, sorry. And I'm going to plug in a 0, 0 for x and y and see if it works. So a 0, 0. So see how I plugged in 0 for x and 0 for y? So then what happens here? 2 times 0. Well, that's just 0. That goes away. So I've got this now. So let's check. Is 0 greater than or equal to negative 3? It is. So that means that this point that's not even on the line, that point made this work. So that means that any point on this side of the line will also make that work. So the way that I show that any point on that side will make it work, I'm going to shade in everything on this side of the line, and I'm going to shade it with one color. Okay, I'm going to shade it in blue. So that shows me that anything on that side of the line will work. Okay, so this picture represents all the solutions to this one right here. Okay, that's all the solutions to the first one, the line and that side. Now, we're going to do the other one. So y is greater than negative x plus 3. So I'm going to write that right here. I got some space. y is greater than negative x plus 3. Now we're going to graph that like we normally do. We're going to start at our y-intercept. I'm going to start at 3. Now, what's the slope on this one? Right, so it's negative 1 over 1. So I'm going to go down 1 and to the right 1. Down 1 to the right 1. Down to the right. Down to the right. Down to the right. Okay, so it's going to look like this, but I'm not going to color it in yet. Now remember, if those points make it work, then I'm going to color it in solid. So I'm going to test it, okay? I'm going to pick a point, one of those points, and see if it makes it work. So I'm going to pick, this time, I'm going to pick, let's see, one of those points. I'm going to pick this one, okay? I'm going to pick, what's that one? 5, negative 2, okay? So I'm going to pick that and plug it in for x and y and see if it makes it work. So I've got negative 2, and I'm going to plug it back into the original. So negative x, so negative x, which was the 5, plus 3. Okay, so let's look. I'm going to see if it works. So what's negative 5 plus 3? That's negative 2. So let's look. Oh, I changed it. It doesn't have an equal then sign. Sorry. So let's look and see the result. Is negative 2 greater than negative 2? No, it didn't make it work. So because this point didn't work, then none of these points will make it work. So I can't color it in solid, so I'm just going to make it a dotted line. And that shows me that none of those points on the line actually make it true. So if you want a little summary, because it wasn't equal to, it didn't work. So this is just a reminder to you. If your line has an equal to sign, you can color it in solid because it's equal to the line. If it does not have an equal to sign, then it's not equal to the line, so don't color this in solid, make it dotted. Okay? So, we're not done yet. So remember, we're focused on this line. So, because it's greater than, either all the points on this side of the line will make it work, or all the points on this side of the line will make it work. So I'm going to pick a point on, let's see, I'm going to pick a point on this side of the line, okay, and see if it makes it work. So I'm going to go back to my trusty old point 0, 0, because it's on this side of that line. It's over here, so I'm going to plug it into this one and see if it makes it work. So here we go. So I'm going to bring this down. So y is greater than negative x plus 3. I'm going to plug in 0, 0 and see if it makes this one work. We already tried it for that one. So I'm going to plug in 0, 0. So let's see, I got 0 is greater. Okay, so let's look. Is 0 greater than 3? No, it's not. So that means that this point, now we're looking at this line, remember? Okay, so that point that on this side of the line did not make it work. So that means that any point on this side of that line will work. So what I'm going to do to show that, I'm going to shade in everything that's on this side. Oops. Everything that's on this side of the line. So I'm going to go and I'm going to shade in everything on that sideline, because that's everything that'll make that inequality work. Okay, anything in this orange area will make him work, and anything in the blue and on the line will make the first one work. But remember, our goal was to find the solution that works for both. Okay, that's what it means. I gotta find a place, or I gotta find x's and y's that make both of those work, the orange and the blue. So where on the graph do you see that it works for both? Well, I can see that this part right here has blue and orange in it. So I'm pretty sure that this area right there is the spot that makes both of those guys work. So if I picked an x and a y, if I picked a point in there and plugged it into both of those, it would make it work. So if you want to, you can, but I'm going to pick a point in that area. I'm going to pick this one right here, and that is, let's see, 2 and 4. So if you were to take a 2 and the 4 and plug it in for x and y into both of those, it would make both of them work. So that's how you find the solution. You have to graph the first one, and remember, if it's equal to, then you can color in the line solid. If it's not equal to, you got to make it dotted. And then you got to pick and see which side of the line, which x's and y's on which side of the line work, and then you find what works for both. Anyways, so there you go. I hope that helps you. Good luck with your homework, peeps.